Hello, good afternoon. Hope everyone had some great lunch this afternoon here in Malaysia. So we want to just thank everyone for joining for another session of Still Connect webinar. So my name is Clarence, and I'm your program host and your moderator for this Still Connect webinar. So before we jump into the big portion, so I just want to do some housekeeping. So today's session is being recorded to be made available for viewing after the webinar. So after this, if you want to review or anything, you can actually just go back to our YouTube channel. We would have a link there whereby you can actually view the webinar again. So for fellow architects and engineers, if you wish to claim your LAM CPD points and BEM CPD hours, please stay through the entire webinar. We will have a QR code and a survey link at the end for you to submit your LAM and BEM membership number. So as usual, we do persuade you to share your questions anytime throughout the webinar in the Q&A session. We will have a dialogue session at the end whereby we will address your Q&A. So it's actually quite easy. So if you go down, so if you look at on the bottom right of the screen, there will be 3 dots. If you press on that 3 dots, you will have a Q&A. So all you have to do is just go to the Q&A and then type your questions there. So a very gentle reminder, please do address to direct the question to me, the host, and then we'll be able to answer your question at the end of the webinar. So let's talk about the topic today. So the topic today is titled The Importance of Testing Your Roofing System with International Standards for Different Building Types. So as the topic suggests, we will have our speaker, Mr. Cheah Haur, who will be breaking down different test methods and performance indicators for both roofing and system products based on international standards. And we will also talk about how we can apply it to different building types. So one of the scopes we'll be covering for today is that we will talk about the determination of product competency against weight of foot traffic. On the product side as well, we were talking about the testing of roofing product resilience against wind loads. While on the system side, we will touch a bit on understanding sound transmission class, or also known as STC, and its evaluation for an acoustic roofing system. Aside from that also, we will touch on thermal transmission, also known as U value, and the requirements for different building types. So at the end of the webinar, we hope all the participants here will be able to understand more on the importance of testing a roofing system in accordance to international standards, where you can make more suitable and informed choices when you're designing for your next building. So a bit on our speaker today. So Mr. Cheah Haur graduated with a degree in civil engineering from the University of Malaya in 2005, and he proceeded to obtain the Master of Science in Management and Technology from the National University of Singapore in 2010. So he has a solid 17 years of working experience in the building and construction industry, and his work covers civil and structural engineering designs, project management, product development, and also testings. So he has worked in various projects across both Malaysia and Singapore, and some of the largest scale projects he has worked with include the Putrajaya Mosque, the Sunway Primary Extension, road flyover bridges, factories, STEAM campus, and more. So in his current role in BlueScope, he provides technical support to users, including hosting various CPD accredited webinars, much like the one we have today. So without further ado, I'm going to pass the floor over to Cheah Haur.
Right, thanks, Clarence. So I will share my screen now. Clarence, can you see my screen?
Yes, we can.
In full screen, right?
No, it's not. Yeah, now it's full screen.
All right.
Perfect.
All right, sure. Thank you. All right, hold on now. Let me just do some housekeeping here. All right. Okay, let's start it. So good afternoon, everyone. Thanks for being here with us today. So here are all the focus of today. So a bit lengthy, just bear with me on that. So at first, I will just give a very short briefing about cold form steel, or in short form, we call it as CFS. Just bear with me with these 3 alphabet because I will use it heavily in this webinar, CFS, all right? Then after that, I will share about the importance of CFS roof and wall product and system performance, and then which are the most important performance that we should focus in the roofing and walling. And then once the general information about the importance of the performance is shared, then I will deep dive into the detail, shared about the CFS roof and wall product performance. Then after that, we shared about the system performance and how to assess it. Then after that, I believe after the 4 sections about the knowledge sharing that I give it today, then I think you might be able to capture the product or system performance and how we can assess it. All right. Then normally when we talking about the product performance, the system performance, we always talk about the product performance must be assessed or the test must be done by the accredited lab. However, what is accredited lab and why the test conducted by the lab is important for end user and designer? So I will share my knowledge by giving the answer in the last 2 sections. Then after that, we hope we have 15 minutes for the Q&A session, as mentioned by Karen. All right. Okay, without further ado, let's start with the first topic of today. What is cold form steel? Okay, cold form steel, or we call it as CFS. If you Wikipedia it, you will get this sentence. It's talking about that. It explains that it is the common term of steel products shaped by cold working processes carried out near room temperature, such as rolling, pressing, stamping, bending, etc. So either stock bars or sheets of cold rolled steel, or we call it as CRS, are commonly used in all areas of manufacturing. So this is what you can search in the internet from Wikipedia. But in layman, what does it mean? The cold form steel, it means that those products made in steel, but is formed or shaped into the profile in room temperature. So cold form steel can be used as such as structural products or architectural products. So as shown at the left-hand side of this slide, let me just point it out. Is this one? All right. It is the cold form steel is in the structural products. It can be either like purlin, like batten or decking. Normally the steel thickness will be ranged like, for example, 0.75 mm to 3 mm. Whereas on the right-hand side here are the cladding products, or we normally call it as architectural products. So the steel thickness may be ranged from 0.42 mm to about 0.6 mm. So our focus for today is mainly on the architectural products. All right. So in common, cold form steel is fabricated by roll forming process in the industry we are using now, because it is the most productive method. Roll forming is the shaping of the steel coil in the cold state to manufacture the long length products, and it can be done by normally can be done by roll former in the market. It is the process where the coil is unwound and passed through number of pairs of mating profile rollers, which is something like this. All right. Each roller is designed to progressively develop a profile predetermined increment, which means it gradually to bend the flat steel into a certain profile. So as shown in the illustration graphic in this slide, either this one or this one, the coil or the flat sheet is fed into a series of rollers, and then each rollers take the part in bending the steel sheet to form to the designed profile shape. So at the bottom is some of the photo to show you in actual life how the roll forming looks like. All the rollers in the series to mating it and the profile or the flat sheet into the shape. Okay, as I mentioned earlier, cold form steel can be either done by rolling, pressing, stamping, bending, etc. Right? So why the roll forming is the most popular method to be used in the market? So in other words, why the manufacturer or the supplier do not use the pressing or stamping or bending method? Right, here is the 5 reasons why roll forming is the best choice to produce a cold form sheet products. At first is the high productivity. Using roll forming method is able to produce high volume of the end product in short period of time if compared to other methods. All right. Then second is about the high consistencies of the profile. By using roll forming method, the series of rollers that you can see in the last slide are able to form the shape consistently from the beginning until the product is produced. Compared to pressing, stamping, or bending, there may be involved a lot of manual work, so the possibility of human error is very high. Then third is the low cost, the lower cost of the labor and the material. Why? Because as mentioned earlier, we might need more labor to be involved in other methods. So because of more manual work is involved, so there may be have create more wastage also. All right. Then point number 4, which is the most important and high ability of producing the long continuous length. So in roof and wall design, normally we prefer to have a long length, and the reason is very straightforward because we try to reduce the joint as much as possible. So more joints that maybe will increase the possibility of water leakage also, right? So that's why the long length roof is very important, and the way to produce the long length roof with the consistency of the profile, so the only method can adopt, which is roof forming. And lastly, which is this one, which is roof forming is able to produce a complex profile, which pressing, bending, and stamping cannot do it. Complex profile will create more room for the designer, for the imagination for the building design, right? So this is the short introduction about the view. So at come to this, I just hope that you already understand what is CFS and why roof form is most commonly used in the market. And each CFS product that you can see in the market was went through an engineering design process until the quality product was produced. So CFS product actually cannot categorize as commodity products, but it can be defined as a specialized products that is designed with a purpose. So I believe all of you should know that the function of CFS roof and wall products, right? And I think most of you maybe answer the question is CFS roof and wall products, which is the cladding to case up the envelope of the building, right? However, if we ask ourselves in detail, do we really understand what are the important for the product and the system performance of CFS roof and wall are? So maybe all of us maybe have different answer, right? So therefore, I hope that I can give you a short answer that what should we really focus on the product or the system performance when we deal with the CFS roof and wall products in the project, right? Okay, basically, we should separate the performance of CFS roof and wall into the product performance and system performance. So what the difference are? So product performance is mainly focused on the mechanical properties of the CFS roof and wall sheeting, which is the example as shown in the left bottom here. All right, just the sheeting itself. Okay, this is called product performance. The mechanical performance means that the CFS roof and wall sheet should be able to withstand the gust wind by not letting it blown away from the roof structure. And then secondly, is the CFS roof and wall sheet should be able to support the human traffic load, which means the sheet should not give way when people walk on it. So the short videos as I shown just now, we shown all the best example of the roofing sheet that is not fulfilled to the basic mechanical performance of the roof and wall sheeting. All right, next is about system performance. The difference of the system performance compared to product performance is the assessment to the system performance is no longer just focused on the CFS roof and wall sheets, but we as a whole system that combine with different components such as the insulation layers, aluminum foil, substrate, etc. This example as shown in the bottom right here. So this is called system performance. It's no longer just the roofing sheet. It's all the components combined together to let the whole system to perform as one. All right, so regarding the system performance, we will assess the performance of the whole built-up system in terms of heat and sound insulation, which means we need to ensure that the built-up system is able to reduce the sound and heat from outside of the building into the inner space and provide a comfy living space for the residents. All right. Normally, the built-up system design is based on the designer requirement because different building type will have a different level of acceptance in sound and heat transmittance. So I hope you already captured the concept about what is product performance and what is system performance and what the differentiation are. Right, we understand about what the product and system performance and the differentiation, right? However, how can we assess the performance? Here is a summary of the tests that we can do to assess the product performance and the system performance of the CFS roof and wall. In order to know the mechanisms of the CFS roof and wall product, we can carry out wind uplift tests to understand whether the product can withstand the design wind load. Then we should conduct the foot traffic performance test to ensure the product is able to support the human load and also certain construction load. Then regarding the system performance of CFS roof and wall product, we shall carry out sound insulation performance tests and heat insulation performance tests to ensure the built-up system match with the design requirement. So I will share about the detail of these 4 performance and how to assess it in the following session. Okay, let's start with the CFS roof and wall product performance and how to assess it. So before I start, I would like to emphasize it again. The product performance is mainly focused on the CFS roof and wall sheet, which is as shown in this slide. So mainly for the sheet only. It's not about all the content inside. Okay, let's start with how we assess the mechanical properties of the CFS roof and wall sheet in terms of the wind uplift performance. Different building type require different wind uplift performance. For example, warehouse and factory might need a similar wind uplift. Sorry?
Yes, you're back, Chow. You're back.
All right. Okay. So should I just go back to the previous slide? Or
I think previous slide, just now we got stuck in the previous slide.
No problem.
Thanks, yeah.
No problem. It's okay. Okay, let's start with this section again. So sorry on the technical. So, okay, let's start with the CFS roof and wall product performance and how to assess it. So before I start, just to emphasize that the product performance is mainly focused on the CFS roof and wall sheets, which is as shown in this slide. So mainly it's talking about the CFS roof and wall sheeting. It's not talking about content or other properties. It just focuses on the CFS roof and wall sheet only, all right? Okay, let's start with how we assess the mechanical properties of CFS roof and wall sheet in terms of the wind uplift performance. So different building type require different wind uplift performance. For example, warehouse and factory might need a similar wind uplift performance on the CFS roof and wall, but residential maybe require a little bit lower performance, and terminal maybe need the highest performance in terms of the wind uplift performance. All right. So before we talk about the CFS roof and wall wind uplift performance, let us understand what the criteria to determine the wind uplift intensity on the roof and wall. Okay, in layman, it means that what are the main factors that may create different wind load level on a building. So I would like to give a little bit more detailed explanation about wind load. It is the load from the wind when blow to the building and apply onto the roof and wall sheet and tends to disengage the roofing sheet from the building or from the structure. So this is called wind load. Right, so the main factors that determine the wind load on a building are whether the building located at the open field, is the building located at on a high terrain or low terrain, and is the building designed with a big volume or small volume, and is the building is designed with a lot of opening or is designed with the confined area. So the wind load that happen on a building envelope will be higher if a building located at open field, high terrain, big volume, and confined area, right? Right. Therefore, different building type might be having different wind load on the building envelope. For example, normally at field and also in the big volume and confined area. So it might be having the higher wind load compared to other buildings. Whereas factory and warehouse might be having a lower wind load compared to terminal, although it's designed with big volume, but it is not located on an open field and it might be having more opening than the terminal. Then lastly, residential might be having the lowest wind load compared to terminal, factory, and warehouse because it is designed in a small volume, more openings, unless it is located at a high terrain or open field. So generally, the wind load will be calculated by engineer based on the local design standard, and then the builder will construct the building envelope according to the requirement. All right. So no matter which position are you in the industry, either you are the builder, architect, engineer, or even you are the homeowner, when manufacturer or supplier submit their product catalog to you and recommend a few products to you, how are you going to assure the products are able to resist the calculated wind load by the engineer? Or which product is the best, right? So in order to answer the question, let's explore the local requirement MS 2005 or Malaysian Standard 2005. So refer to MS 2005, clause 4.3.2, calculation and test of mechanical resistance. It stated that the requirement of wind uplift of the CFS roof and wall This is very lengthy sentences in this clause, but I will not go through in detail word by word, sentence by sentence. I will just pick up the answers that are already highlighted in the green line. All right. So refer to the first green line, which is the point 1. The clause allows the user to do calculation or testing to verify the wind uplift performance of CFS roof and wall product, either the national regulation or MSEN 1993-1-3. So the national regulation means MS 2523, mainly focus on the testing, but the MSEN 1993-1-3 is mainly on the CFS design, right? Then refer to the point 2, the clause stated that no matter calculation or test method is used, it is mainly deal with the trapezoidal or sinusoidal sheets, which is as illustrated at the bottom left here. Those corrugated wavy profile is categorized as the trapezoidal or sinusoidal sheets. So in other words, that all those screw-fixed corrugated product performance must be verified either by calculation or testing. However, refer to point 3. The point 3 stated that the tiles, standing seam sheets, and concealed fixed sheets do not fall under a structural requirement, and testing done by the manufacturer should be trustable and the results are acceptable. So the bottom right in this slide indicate the profile of tiles, concealed fixed profile, and standing seam profile. Right? So in summary, according to Malaysia Standard 2005, which means that screw-fixed corrugated product, the wind uplift product performance must be verified either by testing or calculation, which is either trapezoidal profile or sinusoidal profile. All right, this is all the profile that must be verified by either testing or calculation. Whereas tiles, concealed fixed products, or standing seam to be verified, but on the test have been carried out by the manufacturers. Okay, now come to the key question. Since MS 2005 allow us to choose either testing or calculation to verify the screw-fixed corrugated product performance, right? So which method should we use? And which one shall be the easiest way and more accurate way to get the performance of the screw-fixed corrugated profile in terms of the wind uplift capacity? Okay, before we answer the question about shall we do testing or calculation to verify the product performance, let us explore how many failure mode there's a possibility occur on the screw-fixed corrugated product. Right? Okay, in most of the time, there are players in the industry that intend to use the section moment capacity to calculate the section capacity of CFS roof and wall, intend to prove the bending performance. Our CFS roof and wall product mostly will fail before the product is yield. So normally, the CFS roof and wall product will be filled in either the connection failure or the local buckling. All right. So in other words, is before the CFS steel is in the yield stage and then fracture, actually the profile already failed. So what happened is how we determine the roofing sheet is failed is when the roof and wall is disengaged or local buckling is occur, the product is deemed as failed. So therefore, in layman is we won't see any roofing sheet to be tear off or fracture, hardly to see that. But normally when the gust wind coming in, the roofing sheet will fly away by the connection failure or local buckling. So as such, the calculation should not just focus on the section moment capacity, but the connection calculation and the CFS section buckling failure shall be taken into the consideration, right? So these are the example of the potential failure mode on the connection as shown in the left-hand side here. There's a 5 failure mode here, right? On the top 2 failure mode are the tension failure of the fastener and pull out of the fastener from the support, which is purling. So just bear in mind that in these 2 failure mode, there's nothing related to CFS roof and wall sheet, but it's mainly focused on the screw capacity. However, there are another 3 failure modes, which are the pull over, the pull through, and the gross distortion of the sheet. These are the failure depends on the CFS sheet capacity. So there are some example to show the actual failing with these 3 failure mode. So either is pull over, pull through, and local distortion. All right. The another failure mode is called local buckling. Local buckling means that the sheet will bend locally, but the connection is still intact. This is an example as shown in this photo here. All right. So I would like to highlight that each failure mode is not constantly happen on one product, and it is not happen once at a time, which means that the product may be failed in the connection failure or pull over or gross distortion of the sheeting in one case, then the same product may be failed in the pull over and pull through. So in some cases that the local buckling is happen together with the connection failure also. So in short that there are many combination of the failure mode that may be happen to the screw face corrugated product. Okay, now another critical question. Since there are at least 5 different failure modes in connection and various buckling failure mode, right? So these failure modes also do not happen constantly, and there are mix of the different failure mode in the cases. So how many combination shall we get based on this assumption? 5 connection failure, and maybe you consider 1 buckling failure mode. So how many combination? The answer is there may be approximately at least 63 combination, and it is only applied for 1 span type and 1 steel thickness of CFS only. So if you would like to know the product performance of different span type and steel thickness of CFS, the 63 combination shall times with other possibilities. As such, if you would like to verify the product performance by calculation, you may need to do multiple calculation in order to cover all the different combination and possibilities. So, in order to avoid many calculations to cover the combination and possibilities, the answer of the question is pretty obvious now. Testing might be the easiest way to get the accurate answer to verify the product performance of CFS roof and wall. And yes, the testing is the easiest way to get the accurate result or the wind uplift performance of CFS roof and wall. But how easy it is and how to do it. So refer to this slide. Actually, we can conduct the wind uplift test according to many different international standards. Even MS 2523 have mentioned about it. And also AS 4040.2 from Australia, ASTM from America, and ASIN, even GB from China, even UL also. All right. So no matter which standard you adopted, the principle of the testing is very similar. The workflow, as shown at the bottom, is show the way how we conduct the wind uplift test. At first, okay, we just set up the testing according to the international standard. Okay, then we test the product in serviceability and strength load state. Then after that, we apply the safety factor or the reduction factor to the test result according to the international standard requirement. Finally, then we will determine the product wind uplift performance and publish it, the data for the design purpose. So I would like to highlight that all the published data or any data that's submitted from the manufacturer, the wind uplift capacity is based on the product shape and the base steel thickness, or in short, we call it as the BMT. So the change of the product shape or even change in the BMT will produce different result. All right. So in other words, let's say today there's a manufacturer or supplier A already commit the wind uplift performance based on a certain profile and BMT, submit to you the result, the test report. Then there's another manufacturer or supplier B that's coming and saying that, you see, the profile is more or less the same. And I can give you a little bit cheaper because the steel thickness is thinner. So, and then I can commit you perform the same. Then I would just suggest you better get the test report to verify it before you commit it. Because different thin gauge, different thickness, and different profile will give you a different answer of the wind uplift capacity. All right, let's explore the recommendation in MS 2523 about the wind uplift test. Can refer to Malaysia Standard 2523, Clause 6, bending test at mid-span, subclause 6.1 loading. Section A, it gives the reader open option in how to conduct the test. The code recommended that the test can be carried out by either pressure bags or vacuum chamfer or uniformly distributed gravity load. So refer to the section D, the code give more detail about how to conduct the test if uniformly distributed load method is adopted. All right. Let's take a look how the uniformly distributed load methods recommended by MS 2523. So a lot of people, when read the diagram, they would think that this is the point load or the concentrated load test. But however, this is just the way that they use the point load method, but distribute the load onto the sheet to assess the performance in bending. Right? The concept is very simple, that we just install the CFS roof and wall onto the support and then apply the uniform load onto the sheet. After that, then we assess the performance based on the serviceability and strength load, which means we check on the performance on the deflection and the failure strength. All right. Okay, let's see how the test is carried out by using the pressure bag or the vacuum chamfer. So since MS2523 did not specify how the test should be conducted, so I used the AS4040.2 as an example here. The CFS roof and wall sheet are installed onto the chamfer. As the normal way that we do on the building envelope, we just install it according to what we normally do on the then in fact, we just apply the direct air underneath the CFS roof and wall so that the product receives the uniform pressure. Then we conduct the test similarly to the uniformly distributed load method at the serviceability and strength stage. Right. This is the video to show that how the wind uplift performance according to AS4040.2 in the chamfer. Okay, we have two methods, right, for the wind uplift performance test, and both refer to different standards. So what are the difference in between them? So I'll summarize it into this table. Yes. Both methods conduct the test in two stages, which is serviceability and strength. And the main difference in the way to determine the deflection limit in AS4040.2 is they first calculate the deflection limit, which is span over 120, plus the maximum fastener pitch divided by 30. Then this is the deflection limit to be set. But refer to MS2523, the serviceability stage deflection is according to span over 150, right? And then both standard require CFS roof and wall achieve the maximum allowable residual deflection at the span over 1000. So what does it mean is, during the serviceability, you will blow up the roofing sheet, right? It will bounce up. So when the air release, the pan or the sheet shall be bent back. So shouldn't be using the bend back. Should be back to the flatness as beginning of the test. And then they just allow that the deform of the sheet is only allowed span over 1000. So let's say the span is 1005 mm, you're only allowed to deform 1.5 mm, all right? And then carry out the strength load test by test the specimen until we feel both standard is same. So in short, the requirement of those standard is quite similar. All right, let's take a look of another product performance of CFS roof, which is the foot traffic performance. However, are there any difference requirement in this product performance in different building type? Okay, let's explore it now. Okay, how we determine the foot traffic capacity of CFS roof product? So refer to this graphic as shown, it's already give you the answer. So it means that the one point based on a certain support spacing. Okay, the support spacing normally is refer back to the wind uplift performance of the product. But on top of the wind uplift performance, we must ensure the foot traffic capacity is checked and assure that the roofing sheet can support the human load or certain construction load during construction or even maintenance time. So otherwise, the roofing sheet may be collapsed even before the wind load happened on the roof. So the example as shown in the short video in the beginning, this is the bad example that if you not check on the roofing sheet performance, the foot traffic based on certain purlin spacing, then it might be refilled when people step on it, even before the roofing sheet is fully constructed. Okay, due to the roof foot traffic capacity is the add-on checking to the CFS roofing sheet after the support spacing already determined based on the wind load, so there is no difference in between building type. So in all building type, you need to check on the foot traffic load on top when the, just maybe put it in simple way is, whatever building type, whenever you already design the roofing sheet according to wind uplift performance, on top of that, you need to check on the foot traffic performance. So no matter what kind of different requirement on that. Okay, once again, you come to the question, how you know that the CFS product that you use is safe to support human traffic load based on a certain support spacing, right? Okay, in order to answer the question, let's explore the local requirement, Malaysia Standard 2005 again. Okay, refer to MS 2005 Clause 5.2, Mechanical Structural Properties. It stated the requirement of the foot traffic capacity of CFS roof. So once again, I will not go through the word by word, sentence by sentence. I will just highlight those is very important in green light. So refer to point 1, the concentrated load capacity of roof product must be determined by refer to MS 2523. All right. Then point number 2, we give another option. This is an open option given to the manufacturer. The manufacturer is allowed to use other method, but must state it in document. So you must put it in the document that what kind of standard you are used and how to do it. Okay, so here are the two international standards that can use to assess the foot traffic performance of CFS roof. So of course it's MS 2523, and the other one we recommend to you is AS 4040.1. Okay, actually both standard is sharing the similar testing procedure. So refer to the workflow here. Okay, the step one, as what I described just now in the wind uplift performance, we just set up the testing according to the international standard, and then we apply the serviceability load. This is something different to wind uplift performance. We first apply the serviceability load first, then we check on the deflection. Once the test is past the serviceability load, then only we are allowed to get into the next step to assess the strength load by apply the higher loading onto the roofing sheet. Then lastly, we determine the effective span length that can support the human traffic load or construction load. Then we publish it for design purpose. So once again, as I highlighted just now, no matter which manufacturer supply to you, you must assess that how it come out the result, the test report or calculation. And once they commit on the profile and thickness, this is the thing that you should able to resist the foot traffic by using the CFS roof and wall. However, if another people submit another product to you which looks similar, I think you better get this test report to verify whether it can comply accordingly. Right, I would like to show you the example of how the concentrated load test is conducted by using refer to AS 4040.1. At first, we set the deflection gauge underneath the roofing sheet. So underneath this roofing sheet, there's a deflection gauge. Then we apply the point load. This is the point load, right? We use a hydraulic jack to put it on until the loading achieved 924 Newton. 924 Newton, which is equivalent to 92.4 kg, which is adult human load, which means that you just imagine that a adult human stand on the roofing sheet with 1 foot on it. So we must at least pass this as serviceability. When we achieve the 924 Newton, then we hold it for 1 or 2 minutes. Then we see whether the roofing sheet back to the flatness. If it is back to the flatness, that means it passed the serviceability. And then we check the residual deflection, whether it comply, span over 1000. Then upon the serviceability, it confirm it passed the requirement. Then we go through the strength load test. Strength load is we will apply the loading up to 2475 Newton, which is 247.5 kg for 1 point load, to ensure that the profile can take the certain load and then back to the flatness again. So if the back to the flatness, then you deem that this profile is past the serviceability and strength load. So the example of this video is shown that actually it already conduct 2 stages and the profile is back to the flatness without local buckling, without any opening, and without any deformation. Then this product is past the concentrated load according to AS 4040.1. Right, in comparison of 2 testing standards, which are the AS 4040.1 and MS 2523, actually both methods sharing the similarity of the testing principle. However, if you refer in detail, AS 4040.1 is more stringent than MS 2523. Refer to the summary table. Actually, both standards carry out the test in 2 stages, which are the serviceability and strength. However, AS 4040.1 requires the point load apply the testing specimen to be higher than the compared to MS 2523. The serviceability load is 0.25. Oh, sorry, there's a typo here. Okay, so there's a 924. Sorry, there's 924 Newton, which is 0.924 kilonewton, compared to MS 2523, which is 0.9 kilonewton, which is AS 4040.1 is a bit higher in the serviceability load requirement. And the most different is coming from the strength load. Actually, AS 4040.1 requires the strength load to be achieved double, almost double from the MS 2523, which means the strength load have to be achieved 2.475 kilonewton, whereas MS 2523 is just required to achieve 1.26 kilonewton. All right. So in other words, if the product can comply AS 4040.1, it should be deemed that comply to MS 2523 already. Okay, we've done the CFS product performance and how to assess it. Let's take a look on the CFS roof and wall system performance and how to assess it. So once again, I would like to highlight that the roofing wall and roof and wall system means that the multiple layer underneath the CFS roof and wall, they combine and act as a built-up system as a whole to resist heat and sound performance. So the graphic as shown is a built-up system that we will use this as an example to talk about it in the subsequent session. Okay, regarding the sound insulation performance, I think most of the audience who participate in this webinar should know that different building type require different sound insulation level. However, how much different and how we assess the sound insulation of a built-up system? So let's take a look in detail now. Okay, at first, let us understand what's the level of the noise that may be annoyed residents who stay inside a building. So refer to the table on the left-hand side here. The moderate sound level should be around 60 to 40 dBA. So the sound level that over 60 dBA onwards might be starting to make people feel very uncomfortable and annoying. All right. So refer to the illustration graphic on the right-hand side here. The sound transmission class is the capacity level of a built-up system to reduce the airborne sound noise from the outdoor to the indoor, and we call it as a STC. Okay. STC shall be determined by the consultant or the acoustic specialist, and that can design the roof and wall built-up system to comply the requirement. Okay, now we know about the STC is the way to measure the capacity of the airborne sound insulation of a roof and wall built-up system, right? But how it works and what the criteria to determine the good or bad performance of in STC. So normally, when we talk about the built-up system, as I mentioned in the beginning of this session, it means that there are multiple layers of the components that combine and serve the function as a whole system. So the components include different insulation layers, such as mineral wool, glass wool, cement board, gypsum board, etc., etc. So the performance of the insulation layer in sound insulation depends on the density, thickness, and number of layers. I repeat again. So the performance of the built-up system in the sound insulation really depends on the density, thickness, and number of layers of the system that you put into this whole thing as a system and insulate the sound. So sometimes, if we would like to achieve higher insulation performance, we will add on the cavity, or in layman, we call it as an air gap, all right, to enhance the performance of the sound insulation. So I hope you already capture how the built-up system provides different sound insulation performance based on different combination of the components and with or without the air gap. So now let me share how the whole built-up system works in sound insulation. When airborne sound from the outside pass through a built-up system, the sound level shall be decreased when come to the inside. However, how we measure the capacity of the built-up system, right? Let's take the diagram as shown in this slide as an example that when we measure the airborne sound level outside a building or the surrounding sound, let's say it's 90 dBA, and then we measure the sound level inside a building or underneath or beside the built-up system, let's say it's reduced to 40 dBA, then the built-up system is defined as STC 50. So very straightforward that you use a sound source to minus off the transmitted sound, then we define that what is the capacity of this built-up system. So in this built-up system, with 90 dBA, come to 40 dBA, then we define it as STC 50. All right? Right, how a built-up system capacity to be determined? So the way I described in the previous slide is very general, and this is not the proper way to assess the capacity. It is because the result will be fluctuated from time to time. So we should determine the sound insulation capacity of a built-up system based on the international standard, and it should be tested in a controlled environment lab. So in general, there are two international standards or maybe more. So this is frequently we can see in this region. So which are the ASTM E90 or ISO 10140-2. The concept or the principle of testing is very simple. We just mount the built-up system onto the void, which is as shown in the black frame here. All right. We just mount the system on top on this. Okay. On this so-called soundproof wall in gray color here. We just mount it on. And then we create a sound source from one side of the wall, and then we receive the sound from the other side. Then we can determine what is the STC level of this particular built-up system. Okay, so we know that what is STC for a built-up system and we know how to assess it. So what are the requirements different building type? So in general, here is the basic requirement based on the different building type. So for example, factory and warehouse may require lower level STC because the transmission of airborne sound from outside to inside the building may not affect the comfortable level of the people who stay inside, right? So as such, the requirement is range about STC 25 to maybe 40. Okay. However, residential building maybe need higher STC on the build-out system because residents in the building require higher comfortable level. Because the reason is very straightforward, because they need to have a good resting and the leisure purpose, so they need higher STC level. So normally it's talking about maybe STC 45 to 55 for residential. Regarding terminal, due to the surrounding sound is extremely high because of the takeoff or landing on airplane, which is talking about 75 to 85 dBA, and also a lot of heavy vehicle transportation. So the requirement STC for the terminal maybe is higher than others. So it's about STC 50 to maybe 60 plus. However, just to highlight that, although CFS roof and wall build-out system play important role in sound insulation of a building, but we cannot ignore the transmission of the airborne sound from other part of the building as well. For example, the airborne sound might be transmitted from the windows, ventilation system, internal wall or ceiling, etc., etc. Therefore, we should not just solely rely on the CFS roof and wall build-up system to play the sound insulation role, but the other part of the building should be assessed as well, right? Okay, next, let's see what the different requirement of the heat insulation for different building types of CFS roof and wall build-up system, and how to judge the level of the heat insulation of a built-up system, and how can we assess the capacity. Okay, the difference of the heat insulation of a building compared to sound insulation is the main area that take the most exposed to the heat from the sun is the roof rather than the wall. So as such, I will focus on the roof system in this section. At first, let us understand how the heat from outside of the building transfer into the inner space of the building from the roof. So the heat from the sun is radiation. I think all of you should aware that is energy, and we call it as a heat flux. When the heat flux or the energy transfer through a built-up system, the temperature from outside should be reduced when it is get into the inner side of the building. So now we understand about the theory of the heat transfer via radiation, right? So how we measure it? So in order to judge whether the roof built-up system can perform required to the heat insulation requirement, we will base on the U value to measure the capacity. So how we measure the U value and what the criteria to determine the heat insulation capacity of roof built-up system. So similarly to the sound insulation performance that I shared in the previous section, heat insulation performance is solely realized on the components and cavity, or maybe you call it air gap, in the built-up system. In addition, that's most important for heat insulation, the component is called aluminum foil. So a lot of people maybe ignore it, they think it's a thin layer, but it's very important in the heat insulation for a roof built-up system. As I explained in the previous slide, the way we measure the heat insulation performance of a built-up system is by U value. So what does U value means in the heat insulation? U value is equal to reciprocal of a R value. So in other words, is 1 over R. So, but what is R value? R value is the total thermal resistance of the external surface plus insulation layers, and then plus the internal surface, and also plus the air gap. So in other words, you just combine all the component and any airspace that can resist the heat from outside to inside together. Let me call it as a R value. So the higher the thermal resistance of the built-up system, you will create the lower U value of the system. So therefore, as low as the U value will give you the higher performance of the built-up system in terms of the heat insulation. Okay, we can test the K value of the built-up system via the lab according to ASTM C518-17, and also you can test it in other method. But importantly is because the K value is defined by this test, how we calculate the R value and U value, this is more important. So I'll explain later. So the testing procedure is very simple, that you just prepare the sample. Some of the lab, you just have a small heat flow meter. This is called heat flow meter, right? Based on the size of the heat flow meter, you have a smaller size, maybe talking about 300 by 300 mm size. You just prepare the whole BR system, just slot it in, and then you assess the heat transfer from top to the bottom. So the accredited lab is supposed to produce the K value, and not only that, you should ensure the accredited lab to produce the K value, R value, and the U value calculation to you according to the local standard. All right, this is very important that you should get the full report of the whole performance. It's not only just give you the K value. Okay, now come to the same question is, what is the requirement of U value in different building type is? The answer is, there's no difference in Malaysia because refer to the Uniform Building by Law, UBBL, Section 38A. It stated that the U value for all type of the building must be 0.4 or lower if the weight of the roof lower than 50 kg per meter square. Whereas if you have a roof, the weight of roof is higher than 50 kg per meter square, the U value of all type of building should be tolerated to 0.6 or lower. So this is just a requirement, basic requirement from UBBL. However, if you refer to the Green Building Index, there's another requirement for the U value. So before I get into detail, let me briefly explain what is Green Building Index. It is a guideline for a building owner to get a GBI rating according to the points that are collected based on a certain criteria. So if a building owner gets 86 to 100 points, the building will be rated as platinum. If you get 76 to 85, then it's gold. 66 to 75 will be silver. Then 50 to 65 will be just certified as a green building. However, you get the point lower than 50, then you are disqualified as a green building. Okay, all right, we know about the GBI and how it is rated. Then let's see how the U value of the CFS roof BR system can contribute the points. Okay, refer to the NRNC, which is non-residential new construction, include the building like factory, warehouse, and terminal. You will be able to get 1 point as long as the U value of the BR system can help the building to achieve the OTTV, which is the overall thermal transfer value, equal or less than 50, or RTTV, the roof thermal transfer value, equal or less than 25. Then you get 1 point. If the building type is resident, you will be getting 1 point if the roof BR system can achieve the basic UBBL requirement and help the OTTV to achieve equal 50 or lower. Furthermore, you can get more points if your roof BR system can achieve lower than UBBL benchmark, and if you're getting lower U value, you will getting higher points based on the type of residential building, such as a landed, low-rise, or even high-rise. Okay, so this is how we gain the point in GBI by using the roof BR system, by depending on the U value. Okay, come to here. I hope all of you capture what is CFS, what the performance that need to be aware when we use CFS for roof and wall in the project, and what the test can be used to assess the performance and how the performance requirements differ based on the different building type. So we know the product or the system performance must be proven or assessed or even test. And then we said about that the test must be conducted by accredited lab. So, but what is accredited lab, right? So in general is when a lab is ISO 17025 accredited, it is defined as accredited lab. So what does it mean? So if a lab is ISO 17025 accreditation, it means that the lab has an acceptable quality management, which is quite similar to what we have for the other ISO standard like 9001, 14001, etc. However, for ISO 17025, on top of the quality management system, the standard will assess whether the lab has the ability and the competence to provide the testing or the calibration result. So different country will have a different accreditation body and have different logo to represent the authorization of the accreditation. So at the bottom of this slide, shown that there's a 4 accreditation body, which are the Singapore Accreditation Council, Ministry of the International Trade and Industrial Department Standard of Malaysia, NATA from Australia, and South Africa National Accreditation System. Of course, the accreditation bodies are more than what I show in this slide in worldwide. The reason to show these 4 bodies is because it's close to our market and also the origin of our business. All right, so what are the benefits if the product has been tested in accredited lab? So for end user, the product or the design, for the end user of the product or the designer, what they can gain is if the product is tested in the accredited lab is, they will gain assurance of the competence. Using an accredited lab allow you to have a peace of mind that the competence of the laboratory engage for testing of your products complies to the international standard. All right. Secondly is maintain a high quality. The testing facility are guaranteed to preserve global quality standard through a regular surveillance visit because we need to do annual audit and also minimize your risk. So accredited lab will ensure that your product is competently tested, or then avoid all the risk for retest. Which in other words is, if somebody to show you the test report is not tested in an accredited body, you maybe have a risk that you need to retest it again because they are not accredited. Then from manufacturer side or supplier point of view, you will increase customer buy-in, of course, because you're using the accredited lab, you improve your company image, and also that the report that conduct the accredited lab will be recognized by worldwide. Right? This is the benefit for end user and manufacturer. So now we know that the importance of the product to be tested in the ISO 17000 accredited lab, but why is it so important for the end user and the designer in Malaysia context? Okay, refer to the Law of Malaysia Act 520, subsection 33C in the bracket 1. It stated that the lembaga shall in the manner determined by lembaga certified construction material used in the construction industry and specified in fourth schedule in accordance with the standard specified in that schedule. So I believe most of the audience here may be from Malaysia. You should be aware that the lembaga means is CIDB. So all the construction material shall be certified by CIDB before you can use it on site. So all right, we aware of it, but what are the stated that putting in the fourth schedule here that related to CFS roof and wall? Let's explore in subsequent slide. Right, this is the part print of the amended of the fourth schedule order 2016. Refer to part 2 and 3 in Roman. It stated that zinc or aluminum zinc coated CFS product must be tested according to MS 2005. So that's why that I keep on mentioning about the MS 2005 testing and requirement in the beginning of the session. This is a reason why. So refer to MS 2005, which I already shared in the previous section. In order to comply the Act 520 subsection 33C bracket 1, we must ensure that the CFS roof and wall product must comply to the wind uplift performance and foot traffic performance. How are you going to ensure the CFS roof and wall product can fulfill this law? The only way is to proven by the accredited lab. Upon the product is sent to the accredited lab for testing, end users or the designer can ensure the product conform to the law of Malaysia already, right? Well, regard to the CFS roof and wall system performance, although this is not part of the mandatory requirement by law of Malaysia, however, in order to assure whether the built-up system can comply to your design requirement or maybe your living requirement or not, I think the only accredited lab can give you the firm answer by conduct the test to the system based on the international standard, right? Right, that's the end of my sharing session today. I hope you enjoyed it. I hope it's not too technical to you. Okay, thank you very much. Terence, over to you.
Thank you, Chao. That was very insightful. Okay, okay, I'm a bit conscious of time right now because right now we did send the survey link in the chat, so all of you are actually invited to just put in your survey in the chat. So in case you missed that, and for those who have stayed through the entire webinar, we want to just thank you for that. So now we are going to actually switch gears into Q&A. Okay, we will actually select a few Q&A to address, and then we will apologize if we cannot pick on every single Q&A. We will actually send you the answers separately. But right now, we're just going to jump in on the Q&A. Let's hang on. Okay, the first Q&A came from Johan. So Johan asks, since the wind uplift and load testing for concealed fixed profiles are reported by the respective supplier for their profile and based on their test protocol, could this not mean that the results are uncomparable between suppliers?
Uncomparable, I would define it as, let's say supplier A, there may be tested in other methods, then supplier B, there will be the other method. So to answer this question, I would, sorry, there's some echo there. All right, so to answer this question is, I would say that definitely there will be different standard, will be have a different way to do it, but I was, as I mentioned earlier, all the profile or the CFS roof and wall in the market is unique. although it's the same, but actually it's different. So actually, in terms of the profile itself, product itself is already uncomparable. So you have to rely on whether the supplier using the international standard, but not the in-house standard, is very important. Is if the supplier or the manufacturer they're using the international standard to test the profile of the product, it should be defined that this product capacity is well defined and can be used. So although that different supplier may be different standard, but whoever tests with the international standard should be used as a design for the WinRW performance.
Thank you, Cheah. I guess that one is actually indirectly answers the second question as well, also from John. So he's asking how the difference between suppliers be negated. Is there a globally recognized accredited third-party lab test, which I think is now we actually did cover already.
Yep. So to maybe just let me just simply answer this question is
Yeah.
all right. So no matter it's LISA or maybe other role former, I think it really depends on the lab they engage, whether it's accredited or not. So if the product have been tested in accredited lab, it should be recognized globally. Because I understand some of the role former that may be engaged accredited lab from university also. So it really depends whether the lab is accredited. If yes, then the result should be recognized.
Thank you.
Yeah.
Okay. Next one we have from Arnold. So
Yep.
Arnold is asking, how important is the clips as most concealed fixed profiles look similar?
How important for the clips and looks?
That's
Yeah,
most
this is
common.
I think it's a very good question from Arnold because a lot of clips in the industry look alike and the profile also look alike. So we cannot simply saying that if one product already tested, the rest product will perform the same. It's different story, especially for the clip products. Because clip products, you are nowhere to do the calculation to calculate unclips unless that you have a very powerful final element analysis that you can build all the cases, then you really can so-called to assess the performance. So yes, it's very important that for the clips, for the concealed fixed profile, you must be tested independently. You cannot based on the profile similarity and assume that the performance will be the same. Yeah.
Okay, thank you, Cheah. So I think we're just gonna do one last one, and then the rest of the questions we will address send to you separately. So thank you for that.
Sure.
So just one last question. Since from Lim, so the question is based on our understanding, if U value can be calculated, why do we need to conduct tests to verify the test results?
All right. So this is U value normally you will see in the market people will based on the very simple calculation, based on the K value you have, then you build it in based on the thickness, then you come out the R value. So each independent component actually is tested in the lab and come out the K value. The interesting part is, as I mentioned during the sharing session, is the lab will give you the full calculation, which means that after you test on the K value, they give you the R value, and also they calculate the U value based on local standard. So in other words is, when you send the build-out system to the lab, and then they give you a full report with the full U value calculation, this is the thing that determine the build-out system. But whereas in the market, people were using the Excel sheet, that one will be just a so-called estimation of build system. Because why? There's maybe some people were using different standard to calculate the U value. But from lab, you can assure that whatever the U value they calculate is really comply to the local standard. So that's why it's very important that even though you can come out the U value by calculation, that one is just for estimation. Eventually, you want to prove the performance of the U value. It's better to get it from the accredited lab because they can calculate the U value based on local standard to you. All right.
Okay,
Thanks,
thank you,
Gareth.
Cheah. So I just want to thank you, Cheah, again for sharing us with such an insightful presentation. So I hope everyone has some good takeaways from the session. So I'm gonna just thank you, Cheah. We're gonna jump ahead. Oh, sorry, this one was from just now. So yeah, so for all the attendees right now, so if you have interested or some stories to share, you can actually email in to events@bluescope.com or email to me directly, clarence.ng@bluescope.com. and we can talk about you being our next speaker. So just last one, this is the survey. So I just want to thank everyone. So please, for all those, for those who want to claim your LAM CPD points or your BM CPD points, please do fill in the survey, scan this QR code, and there will be a question inside for you to fill out your membership. So I just want to thank everyone for joining today's session, and we look forward to inviting you to the next one, next week on our webinar. So thank you everyone.
Thank you. Bye.